Hello. Yeah, good afternoon. Thanks for joining us today. Again, a couple of seconds for everybody to join. I see everybody's actively using a chat interface. There is also a Q&A interface. So if any questions will arise during the presentation, please don't hesitate to type in your message, and we will have enough time in the end to answer those questions. So feel free to type your messages into Q&A box or into the chat during the presentation, and we will go through them one by one in the end of this session. Well, I think everybody who was planning to join us on time already managed to connect, so we are going to start right away. Today, we are going to speak about structural verification and checks according to rules and regulations directly in the interface of Ansys Mechanical. I see here today a lot of people from very different backgrounds, from very different industries, from very different approach to how they do simulations and how they do checks according to rules and regulations. I'm eager to learn about your approach, your ideas, your workflow at the moment. So we'll be happy to continue this conversation after. But a small disclaimer that since we have such a broad audience today, I'm going to try to keep this presentation as simple as possible and very broad, explaining the workflow and general ideas of what is possible, and keep in mind that there is a deep blue ocean of features and tools under what I'm going to show to you today, and there is more and more functionalities available. So again, please don't hesitate to ask in the Q&A box if you would be interested in anything specifically, and I will be able to explain that in more details in the end of the sessions. So today we are going to speak about a very broad topic, but I'll try to keep it in a very simple way. So I decided to avoid doing a global agenda. We are basically going to answer three questions or talk about three topics today. First, why simulation in Ansys is great. Secondly, why it is not enough. And what do I suggest to do with this? How do I suggest to overcome this? But before we start, a brief introduction into SDC Verifier as a company and myself. My name is Oleg Ishchuk. I am in charge of operations at SDC Verifier, joining the company as a structural engineer, and now overseeing the operations of the business in general. I have more than 15 years of experience in structural design, finite element analysis, and with SDC, a big focus on rules and regulations. Our team is more than 35 people in 3 countries. We develop multiple software products. We deliver consultancy projects. We deliver trainings. We partner with the best in the industry to deliver our solutions worldwide. We partner with the best to use the most modern and up-to-date technology, and therefore thousands of happy users of SDC Verifier are utilizing this globally. As I already mentioned here, the group of people that we've gathered here today is very broad, and we have simulation engineers, we have FEA engineers, we have those who are interested in compliance checks to put their product to market, to put their designs for certifications, etc. So there is a broad world of simulations and computer-aided engineering, and you can do so much. And Ansys in this broad world is delivering us or enabling us to do different kinds of simulations. What you can see on your screen right now is one of the simulations we've done quite a while ago. You can see Ansys 19, so more than 5 years ago. And this was a study of a container dropping on the deck of the vessel, and there was some hazardous cargo under the second deck of this vessel. So it was extremely important to make sure that in case of an accident, and these things were occasionally lifted above the deck, in case of an accident and in the most unfavorable condition, it's not going to break through the second deck, and it's not going to cause any harm, and not going to affect those cargo under the second deck. So you can do this kind of simulations with explicit dynamics. You can do this kind of fancy simulations. I'm not speaking about all the possibilities of the finite element analysis, but finite element analysis is providing you with a fairly limited set of outputs. So you have forces, stresses, displacements, maybe some dynamic analysis will give you the strains, the plastic strains, or like in this case, or will give you the energy, the amount of energy, but it does not necessarily answer your question if your analysis is completely okay. So this is one of the reasons why you would have to comply with rules and regulations and with different kind of standards. There is so many of this design codes, rules and regulations, standards, also different societies or different industries and groups of people are calling this documents in a different way. I stick to, well, it's hard to pick one, but we will call them standards today. So you have to do checks according to rules and regulations for multiple reasons. There are a certain amount of, there's many of them. So I would say one of the first is safety and reliability. So making sure that your design is safe against certain failure modes. This is what keeps you as an engineer safe. Because just knowing that stress is 200 megapascals in your structure does not necessarily answer the question if it's going to buckle, or what is the residual lifetime, or is the weld strong enough. So you need to comply with a certain set of regulations that are following the best practices to keep yourself safe and to keep your design safe. This brings us to the second requirement why we need checks according to standard. It's industry best practices. So very often standards are updated, and standards are updated by learning from the industry. So if you use most up-to-date code, you're using most up-to-date way to define if your design is okay. Quality assurance, so just to make sure that quality is good enough. Legal compliance, sometimes it's requirements from the legal team, or for certain industries, for certain designs, it is a necessity to comply with certain rules and regulations just to put it into operations. You cannot build a ship and without a compliance with one of the governing bodies of the certification societies. And last but not least, it's clients and stakeholders' confidence. So it's everybody involved in the process is sure that that design is safe and that is corresponding with most recent requirements. So you might be required to do code check for one of these reasons or for all of them. This is your way to stay safe. This is your way to deliver the results in the way your customer would require. But I would say it's not some fancy addition to the general verification. It is the market demand. So at the moment, market demand. At the moment, we receive more and more requests from our existing users or potential users coming and saying, this is what industry needs. This is what all of my customers asking for. This is what all of my all of the stakeholders of my project asking for. So compliance with rules and regulations keeps you safe, but this is also a necessity. This is also something that is completely mandatory in a certain industries. And this helps you to prevent certain failure modes which you do not necessarily um, see straightforward based on engineering judgment or based on your knowledge or past experience. So you have certain set of outputs, but to make sure that your model is safe enough against the fatigue damage, that it's not going to buckle both in terms of plates or beams, that connections are going to stay intact, and that there is not going to be a damage to the connections, both bolted connections, welded connections, and all types of fancy joints. You need to comply with requirements and with the formulas of the standards that are prescribed in a certain way in the documents by someone doing this check and comparing this to the reality before you. So there is multiple ways. There is multiple different codes in the world. There is thousands of documentation of documents for specific failure modes. There is hundreds of governing bodies and certifying bodies. So there is a lot of these documents. Moreover, these documents are being updated frequently. So every couple of years, the governing bodies release a new document. Sometimes the changes are minor. Sometimes the changes are crucial. So you have to stay with up to date with those codes. And today we are going to speak about this, how to do that. I am eager to know how you are doing checks according to rules and regulations. I see some of our customers in here, so I'm pretty sure I know how you do this, but also many new people. So I'm wondering what do you do, because there is a couple of alternatives. You rather do it as a hand calculation, so yeah, I hope nobody uses these whiteboards anymore, but in slightly more automated digital way, you can also do this with a spreadsheet or with the MATCAD or MATLAB file, or a certain amount of automation. But again, as I mentioned, there is plenty of changes to this code. So if you have a script, or if you have a spreadsheet, or any kind of half manual workflow, it is going to get outdated as soon as the new version of the standard is being released, or as soon as your design becomes non-typical. So our workflow and our approach is to do this directly inside of the finite element analysis software. So we suggest to do checks according to standards directly inside of the interface of Ansys Mechanical. And this is what we enable and provide engineers with, and this is what we make possible. SDC Verifier is Ansys solution partner. We are developing this application in the partnership agreement between us and Ansys, and this allows us to get most up-to-date information about new releases of Ansys. It allows us to stay updated with new versions. So as soon as new version of Ansys is being released, SDC Verifier update is following. Moreover, our broad team allows us to keep this up to date for multiple different applications, industries, and regulatory bodies. What you see today, will see today, is applicable to many different industries. I will try to show something more generic, but pretty much every big structure that has to comply with the rules and regulations from different industries is possible to solve that with Ansys and post-process with SDC Verifier. So most applicable, I would say, the biggest industries for us would be oil and gas, civil engineering, offshore and maritime, all kinds of machinery, equipment, and devices, lifting, heavy lifting, port equipment, and any kind of access devices, lift platforms, etc. Aerospace, piping and petrochemical, pressure vessels, railway industry, renewable energy. We recently did a lot of research work to automate DNV RP-C203 for foundations for the floating wind. So a lot of applications over here, and of course defense industry as well, where you have big structures that has to comply with a certain set of rules and regulations. That's enough about the introduction into what is the application for this and why we come up with the idea of this and doing this for 15 years already. Now I would like to demonstrate a little bit more how do we do this. So we will start with the interface itself. SDC Verifier is enabled through Ansys Workbench. So after you have SDC installed, you will have code checking and reporting tab directly in the Workbench, and all you have to do is just to pick the item of SDC Verifier and to drag it into the project schematic to be able to. So maybe I'll start again. So you select the item of SDC Verifier, pick the portion of the model where you would like to connect to, and enable SDC Verifier connected to your specific set of data and analysis in the Workbench schematic. After this is done, SDC Verifier can be run as a completely embed software into the interface of Mechanical. So you would have a tab of SDC Verifier with main features, so like opening a project and running basic tools, as well as a complete set of different standards, rules, and regulations, and then post-processing, automation, open APIs, etc. And portion of SDC Verifier would be then directly in the tree of Mechanical, so you would be able to access all the features of SDC from the Mechanical. As soon as you pick any of this, let's say standard, you will have a new window that appears and starts a dialogue between an engineer and the tool to set the parameters to run the checks. Alternatively, it can be run as an independent interface for those who prefer to have their Ansys model on one screen and SDC Verifier on another. It is a convenient way to have everything within one window. Then all of the features of SDC Verifier are conveniently sorted into the ribbon items, and you have a project schematic once again, and everything you would open in this schematic will start in this main window in this what is big gray space at the moment. Now I would like to proceed to one slide, which I usually use to explain the complete idea of SDC Verifier and to explain the complete process with SDC. Basically, with this circle, you have 5 main steps, which are explaining basically the steps you have to take to run the procedure of verifying your model according to design codes. So we start with the simulation. It's your model in your environment inside of Ansys Mechanical. So you build a model in the way you are used to. You apply, you use the element types that you find reasonable for this design. I would suggest, as always, to stay to keep as simple as possible. If your model is simple enough to do it with beams, and you foresee that you will need to run beams and joint checks, even some welds and fatigue checks on a simple model and very generalized 1D interface, use 1D elements. If you see that you need more complex design, go to 2D. If your design is very complex and you need to do specific studies, then use 3D elements. Anyway, SDC works with all of them. On the second step of this workflow, we are enabling user with the possibility to combine the loads in a certain way as prescribed by a standard, or to apply specific loads, wind load, snow load, waves, specific boundary conditions, distributed of the weight over the sections of the ship, etc. So many different applications where you can benefit with a bit of automation. We have Not all of it, of course, but we have a lot of automation for loads and combinations. But nevertheless, we are using your outputs of Ansys Mechanical. If you have your model solved with all the necessary loads combined, it's completely okay to proceed with code check directly on this model. Then we have what we call recognition, and recognition is basically it is detection of structural members out of finite element analysis model. So your model in Ansys is 10 million of finite elements, but you need to know where are the welds on it. And you either need to model the weld, which is tedious process and very time consuming, or you need to automate this somehow and define those welds from your model. What we suggest is this: we suggest to automatically detect the structural members out of mesh connectivity. And then these two items, the load combinations and the recognition, they completely outperform the idea of using a script or spreadsheet or semi-automatic way. Because if you have any kind of basic automation, you check it on one loading condition for one single structural member. SDC Verifier analyzes your complete Ansys model under fairly unlimited amount of loads and combinations, especially if we speak about the offshore structures and sea motions and winds and all of the possible combinations for spectral fatigue. Of course, we have some advanced filtering techniques and rainfall counting, etc. But it is ridiculous amount of loading combinations. And SDC Verifier allows user to run the checks on multiple loading conditions on each and every structural member of your model. By the way, different structural members. From the same model, it is possible to detect the welds, blade fields, the members for beam buckling, depending on type of those elements. So we allow basically all in one. Next item is why we are all here. So the checks themselves. So the possibility to create the verification according to standard. In a simple manner to explain how is this possible, we are taking the parameters of your Ansys model and results of the solution, and we use them as variables to create the formulas of the standard. So all of those formulas of the code are automatically converted into the variables, some of which are material knowledge, some of them are outputs of the analysis, some of them are geometrical characteristics, some of them are defined through recognition, and then general mass functions. So it's basically, well, I'll show later the interface of the formulas or the formulas themselves, so you'll be able to see how it's written. And then last but not least is automatic documentation. It is nice to have a possibility to set up a template-based document which is explaining how your model is built, what are the results of the FEA, what are the results of the code checking. On top of this, we have design optimization, which will take another 40 minutes of your life if I'll start explaining this now in detail, but it is possible to make the best design decisions based on the requirements of the standard. So no guessing of the plate thickness or weld type or cross-section of the element to build your jacket structure. We will pick the best design decision for you, and you will only have to run the analysis once. And last second I spend on this slide is to explain why this workflow is built in a circle, because it is a repetitive procedure. No one ever did a complete check. Well, maybe somebody did, but I didn't see that person. So a complete check from start to finish in one try. There is always a lot of variables. There is always some things changing. There is always something to update. Usually your customer is coming with ideas, how about we change this or that? It's easy for you to update. In reality, it might be not, but with SDC Verifier, it is, because the whole procedure is template-based. So as soon as you need to do modifications, you go back to your first stage. You adjust your design in Ansys, change the model, update the load, modify the design, whatever is the customer request, and the whole procedure is saved. So you go exactly to the very last step and generate the same report, because as you remember here, we have done a templated report. You generate the very same report, but with updated data in a matter of a couple of minutes and literally few clicks compared to complete rerun of everything you've done. This is basically the idea of SDC. Now I will try with a couple of slides to highlight the main features of SDC Verifier for each of those steps. We already talked about the simulation part and connection with Mechanical, how it is integrated. Now let's go to loads and to the loading conditions. What SDC Verifier basically does, it connects to your model and it reads the set of analysis, the set of loads for every analysis that you have in your model, and it allows to use them as the single load input, what we call individual loads. And this is perfectly okay to run the analysis already. So you have a gravity and you want to check if your structure is safe enough under just standard Earth gravity, no extra loading. It is possible to run this. You have maybe from other department output file where you have all of the necessary loads combined. You know which condition is critical and you only want to check that one. It's perfect for you and you can run this. So at this step, we just read your loads and allow you to modify your loads. But very often, the life is not that simple, and there is more and more different conditions and factors to take into account. So the standard is coming with usually a certain table, which is explaining, okay, you need to take your gravity load with a factor of 1.3, add the live load conditions with a factor of 1.2, add an extra amplification coefficient, safety factor, partial load factor, take into account what would happen if the load has positive and negative values, then use the exceptional cases, test loads, put them all into the combination and run the checks both on ultimate limit state and serviceability limit states and different kind of combinations, etc. This is all making the analysis more complicated. You're not necessarily aware which is the governing one or most crucial one, so you need an interface to run them in a simplified way. SDC Verifier allows you either to create this matrix manually from your individual steps. You create combinations by multiplying them with the factor, because most of the standards are based on the linear analysis. And for seeing your questions, I'm already answering. If you need to solve them non-linearly, no worries. You can export them back to Ansys and solve them non-linearly and post-process those results. So you either do this manually, or we have an automatic combination according to most popular standards like Eurocode 0, ASC 7, EN 13001, etc. So you just define which load of which type or a category, and software combines those automatically. Besides this, we can automate complex loading for you, making the possibility to apply them within a single setup and a couple of clicks. So all kinds of distributed pressures over the unknown areas, which are tricky to apply. With SDC Verifier, it is easy, like wind load, wave load, snow load. You just select the portion of model subjected to this load and the direction of the load, and maybe a couple of parameters like wind speed or pressure, and the software applies this automatically. Besides this, more complex loads like pressure of the water in the tank or buoyancy load of the floating structure, which is automatically calculated either by predefined waterline or weight and water density, etc., is automatically applied within SDC Verifier. Again, it is possible it is simple to apply through a set of convenient interfaces. Of course, it's I can explain this more in detail if that's subject to someone's specific research, but for now I would like to move on and to make sure that we have enough time to go through the whole set of slides that I prepared. So within this plan, the next item would be recognition. By recognition, as I already said, we detect the structural members out of finite element analysis model. And what is possible to do is to detect the following members. We can automatically, by automatically, I mean literally within one click, to detect the joints in your model, all of the joints and connections. We can define the beam members for beam buckling checks. We can detect welds completely automatically with no need to model them anyhow specifically in advance. On both shell models and solid models, it is possible to identify all of the weld lines. Then plate fields for plate buckling, panel buckling, stiffener buckling, etc. on different types of models, not necessarily only for ships and vessels, but also for the aerospace, or, well, if you have any kind of plated structure, it might be subjected to plate buckling. So we do define these items completely automatically. And how to do that, I will show an example of only one member. Most common is to identify welds within our software. So the software defines weld lines based on mesh connectivity. So any kind of material change, property change, thickness change, connection of a certain angle, or a contact on both 2D and 3D elements, so shells and solids, is automatically identified as a weld line. Then the stresses and forces in those elements of those weld line are reoriented into the weld direction. So we know them along the weld, we know them perpendicular to the weld, we know them for shear. And we're able to use them as variables in the checks and in the formulas. For fatigue check, we use stresses with certain, well, with reorientation, and then if necessary, it's possible to use hotspot stress method, or if your mesh is fine enough, it's possible to use the nominal stresses. And for weld strengths, we can use the forces and figure out if the area of the weld is, so if the weld is good enough to withstand the force that is going through it. I'll show a couple of the examples in the future, but now first on how this recognition is done. And also I wanted to highlight that it is also possible to identify those on solid elements, which was recently added to functionality of SDC. And this is a big time saver for the specific applications. How does the weld finder look like? Your model in Ansys is probably something like this. Let's say it's a piece of machinery, jib of the crane, any kind of welded structure, which you have built with relatively okay mesh to be solved. But you don't want to spend more time on refinement of the mesh, or moreover on modeling of those welds. So what we do with SDC, we run a tool which is called Weld Finder, and all you have to do within this tool is to click one button, Find. It analyzes your model, it checks the quality of the mesh, that's why you have a notification here with the warning in case if something is not properly connected, or you have mesh disconnectivity, or both elements in both directions can be treated as welded. So this is something to review or ignore. And then you have a list of all of your welds in the model, which can be sorted, can be renamed, can be listed in a convenient way. And you can assign either the weld size for those elements if you're running the weld strength check, or the FAT class for the fatigue if you're running the fatigue check. Moreover, it's possible to use the hotspot stress method to take the stresses from the reference points at a certain distance from the weld line. What we have here, well, what you will have as a result is this. It's a possibility to see all of those weld lines and to use them as a selection for the further checks. It is also possible to set exceptions. So if you know that some properties in your model are not welded, you are able to say, okay, between property 18 and 19, it's a rolled beam, so there should be no there should be no weld. You are able to run this exception, and the software will treat this as an exception and will not include this in the check. Moreover, you have weld tips, so it's possible to set the it is possible to set a different classification, for example, for fatigue check for weld tips. Okay, next part of this workflow would be the standards. So the standards themselves checks according to standards that you would want to run. So what we will have to do in the case of SDC Verifier is to pick which standard you want to comply with and which standard you want to follow. There is a big library of different industry rules in SDC Verifier, which is constantly updated. We are trying to keep all of our rules up to date. We are adding new ones every major release. We add 2 to 5 different standards depending on the complexity, adding different rules, adding different versions, adding different analysis types. So but this library is constantly growing. So if you need more of this, it is of course possible to include. If you're missing anything, this list on the screen is of course not complete, but if you're missing anything, please let us know, because the priority for the development of the standards is depending on the on how much it's been asked to add. So please let us know if you're missing anything or if you need some specific rules in SDC Verifier. How would the user create a standard in SDC Verifier? It is usually done through this kind of dialog windows, where you have to select first the portion of the model that has to be analyzed. It's either all entities or a specific set of elements or nodes. By the way, this selection goes through the complete interface of the software. So it is possible to pick portion of model to solve, portion of model to do the recognition, portion of model to run the check, or to present in the report. This is a powerful tool, which of course can read your Ansys named selections, but moreover, it can help you to define rule-based selections, like based on coordinates, based on connected members, etc., and the results of recognitions, of course. And then you will need to set a certain parameters for those options which cannot be automatically retrieved either from the model or from the outputs or from the recognitions. Like, we need to know your weld quality, so you will have to define the FAT class. You will need to select for Eurocode 2 parameters like consequence of failure and assessment method, which will affect your safety factor. You can set the custom yield and tensile for every materials, so to use something specifically different in the check. And then if you want to use hotspot stresses, if you have defined those reference points, and if you want to use the rain flow counting method for calculating the cycles of the stresses, it is also possible to use those. So this is an example for fatigue, but every standard is having its own set of rules to be defined. And as a result of this is now a different rule. It's an AISC 360. As the result of this, you will have a standard created which has all of the formulas listed, and all of the formulas are open for your convenience. So complete verification procedure according to standard, what we've seen on slide 3 of me today, which is a 500 pages document, is shrinked into a set of checks. In this case, it's pretty extensive. It's 17 checks, but it's also split for your convenience. So you have the geometrical characteristics first, then bending, axial, shear, and combined actions, and then overall checks, which will show you the utilization factor. And if it's more than one, something in your model is not passing the requirements of the standard. So the idea of this open formulas gives you an extreme flexibility because first, you know where your results are coming from. Every formula, every parameter has a description which is explaining, okay, this is coming from table this is coming from table number Z, from the standard itself. Moreover, you have a possibility to modify or add your own formula. So if you need to use custom checks, or if you're missing something in our library and we have not added this yet, but you need this urgently, you can do it yourself. Of course, it's not going to be called Eurocode anymore or AISC, but you can say it is my custom code based on the requirements of the standard, and the software will run this analysis for you. You can share it with colleagues and use for your further routines. So based on this, for every parameter, it's also possible to build a table or a colored plot. Sorry, there's a bit of a delay with my painting now, but you got the idea. It's possible to build a table or a colored plot of the results for not only the final parameters like utilization factor, but also the intermediate parameter, the any parameter from the analysis, from the calculation. More than this, it is also possible to see the complete history of calculation. So for example, this is a buckling check where you run the buckling analysis, the plate buckling analysis for a specific group of elements of a certain structure, and you would like to see, and if something goes wrong, let's say, or the opposite, if the result is too good and you want to save some materials or see how to optimize your structure, you're able to go into every specific element or every specific property or every specific item in your model and see complete calculation history with how it is calculated, which formula is this, and what are the intermediate results from this formula. So it is very nice to track the changes. It is very nice to track the result if you want to understand where it's coming from and how is this happening. And then, of course, we have an interface to preview the results. So it is possible to use the graphical interface of Ansys as well as build different types of tables to present the results. So, for example, if you have a plate buckling, you can nicely put it into a colored plot with the buckling factor for every plate in your model, or have a nice table highlighting not only the buckling factor, but also the critical stresses that are causing this buckling. The same goes for different types of elements. You can present the results of your fatigue analysis with not only previewing the results itself, but also explaining the classification and explaining the SN curve used for the analysis. Or beam buckling, you can demonstrate the results, but also you can run the optimization to define the optimal cross-section, for example, in this case, to match the requirements of the standard. Then moving on, when we are done with the checks, last couple of items of this workflow is automatic documentation and optimization. So we will start with automatic document. SDC Verifier allows you to build a template-based file, template-based document, explaining how your model is built, what are the general FEA outputs, and what are the results of the code check. The beauty of this is not only the possibility to set this document, but as I said, a possibility to store this template for reusing this with the other checks, with either the updated model, modified design, or with updated workflow, analysis workflow, to see the different outputs, to see the different results. And it's not only highlighting the code check results, but it first explains how your model is built, with materials that were used, with the loads that were applied, with the boundary conditions, etc. It gives you an explanation of general behavior of your structure. So what was the loading, what was the sum of reaction forces, displacement table, displacement plot, then you can add stress table, stress plot, code check plot, keep this structure, and then copy for each and every loading condition in your project. So since it's template-based, it's easy to navigate. More importantly, we are now working on bringing this this documentation to the next level with what we call structural asset management platform, where you would be able to export this into online collaboration platform, because report is a classic way of the result presentation, but it is static. So you only have the analysis that were calculated once by somebody, updated in a piece of paper, which is, well, now it's not printed anymore, but it's stored somewhere in the file system on your computer and very likely lost after a certain amount of time. But your structure continues its life cycle, and the data, the design changes, the data changes, the input changes, as well as the output. So it is nice to have an online convenient interface where the owner of the structure and the inspector of the structure and the analysis stress engineer are able to share the data back and forward, updating the information with the most recent inspection data, with the most recent finite element analysis results, most recent information about the loading conditions, to keep this up to date. So this is something we are currently working on. If you have the assets, if you either own the assets like bridges, cranes, ships, wind turbines, which are subjected to repetitive loading and aging and have a certain finite life cycle, it is a nice way of presenting the results, and it is something that we now deliver as consultants also to our customers. So if you're providing consultancy services, maybe this would also be interesting for you. Not only demonstrate the results in the format of document, but also through a collaborative online platform which is updated. Moving closer to the end of this session, a couple of more things that I would like to demonstrate today is one of the feedbacks of our clients, how much time SDC Verifier saved them on the typical workflow. So you see that, a lot of time is saved on hand calculation, a lot of time is saved on working with standard. Reporting is significant, is showing some significant time reduction, which results into 50% of the engineer's workload and time saved for modeling, analysis, and generating the report for the finite element analysis and code check project. So it brings us to the conclusions. What is SDC Verifier? SDC Verifier is an extension to Ansys Mechanical to perform checks according to rules and regulations directly inside of the interface of Ansys. We have popular standards, popular rules and regulations available. Those standards can be customized, modified, and updated. The total calculation procedure is saved. We have extensive reporting. We have design optimization. We have web collaboration platform and many of pre and post-processing tools to make this process transparent and straightforward. And this is what our customers are saying, that in general, in some cases, they did the job in 2 days compared to weeks or months. So the goal, of course, is to make this effective well, design correct, result correct, but also make this in a reasonable amount of time. And this is what we help to save on. With this, I'd like to indicate that there is plenty of companies worldwide in different industries with different applications who are benefiting from using SDC Verifier. We are having lots of different information if you would like to learn SDC Verifier yourself. First of all, myself, and our team are more than open to run the specific demonstration, because today I just highlighted the general introductory explanation of what is possible, but I can imagine that you would like to see the workflow. So you can see that either through our pre-recorded videos on our YouTube channel, or please reach out to us to ask for a dedicated demonstration. More than this, we have a very detailed and thorough help documentation. So if you need to learn about certain features or functionality, you can go to SDC Verifier website. In the help section, you will find help for different products that we have, which has a nice search functionality. So it's fairly easy to find the necessary information. But again, we are always at your service to help with answering the questions. And what I would like to, so this concludes my presentation for today. What I would like you to benefit from and to do in the future, if you find what I have presented today interesting, and if you find that applicable to your workflow, and if you're saying, yeah, I need this check according to API, ISO, Eurocode, NORSOC, DNV, Bureau Veritas, Lloyd's Register, multiple different other codes, it is possible to go to SDC Verifier website, download a version of SDC Verifier for Ansys, and try it for free. So please don't hesitate to download the software through the license manager. You can request a free trial license, and we are happy to assist you with all of our support capabilities and technical background to reach your goals in the automated and more pleasant way. And last item last but one slide in my presentation, I am inviting you to subscribe to my LinkedIn, where I try to regularly share the updates about the structural engineering, about finite element analysis, about checks according to standards, and some of my personal thoughts. So happy to connect with all of you through the LinkedIn. And if there will be any further questions after this session that will come up into your mind, don't hesitate to reach out to us by phone or email or Teams in the social media, or even in Skype. So we are really findable on the internet, I think. So in case of any questions, feel free to connect. Now I would like to go through the Q&A session still. So I see there are some questions in the Q&A. One of the question was, okay, if the size of the weld is not specified, is the thickness inherited from the shells or solids? There is two ways. So you can run weld verification on both shells and solid, but the size of the thickness of base material, of course, is read from both shells and solids from the connected plate. But for running the weld check, you need to specify the size. You can select all of the files in the you can select all of the files in, all of the welds in the list, and just assign everything is full penetration, which will assign your weld size as a thickness of the connected of the welded plate. But you can also run single fillet, double fillet, full penetration with a certain dimension. So there is a convenient interface in Weld Finder to define the size of the welds. So please go over to that, and if you need any help with this, we'll be able to demonstrate that to you. Then there is a question about the rail industry. I was working with my colleagues from the rail industry demonstrating some of the codes for them, and we have a customer. I'm not sure if I'm allowed to name the customer, so I will just say that they use SDC Verifier in Europe for the railway car design, and there is a couple of common codes. If we speak about the welds, there is German standard FKM, but there is even more common standard DVS 1612 and 1608. One of them is for steel, another one is for aluminum, and they are commonly used in the rail industry. And then for all of the bolted connections, it is advised to use VDI 2230, which we also have. So besides the general steel codes, we also have the specific ones for the rail industry. But I think that also your customer would point you out to the specific regulation that you need to follow. And they are all, a bit of a secret here, they are all referring in one way or another to the basic code. So there is the Palmgren minor rule and S-N curve method for fatigue. And what is different between different fatigue standards, it's just the material properties, S-N curves, and factors and characteristics. So the logic is already there. So we are happy to add that for you if required. Then I see there is a question about the versions of SDC Verifier, I think, and Ansys. I think I already answered that in the beginning of this session. We are following the versions of Ansys new releases with yeah, I see more questions popping up. We are following with the new releases. So as soon as Ansys releases 2025 R1, in a couple of weeks, our new version of SDC Verifier 2025 R1 is going to be public, supporting this version. And we are supporting all of the versions from 2018 up till 2025. So 7 years of most recent Ansys versions are supported with SDC. Question is, can we do bolt calculation in SDC Verifier? Yes, you can. We can do AISC bolt check. We can do Eurocode bolt check. We have VDI 2230, where your connected plates are modeled as 2D elements or 3D elements, and you have all of your bolts modeled as a 1D element in between. We can extract the forces from each and every bolt and check axial force, shear force, slip resistance for the bolted connections. It is possible to also load those elements from library, or we even have an semi-automatic check on checking the bolted connections on 1D elements. So there is a lot of functionality to run bolt checks in SDC Verifier. And another question I see about the plans to add Eurocode 9 in SDC. It is in the short list. I'm not sure, to be honest, if it's in the short list for this version, but it is in the list of the codes for the development. I will be able to check later today when I'll make a copy of this question for myself. And so I will answer to you by email. I think we have your name through the registration when SDC will have Eurocode 9 in the library. Okay, I think I went through all of the I see, Andrea, that we need to add Comau to the list of the customers on our slides. We'll do that right away. Bohdan already answered that. We'll do that. Thanks for joining us today, and I'll explain. Bohdan will send you an explainer about the well sizes. Meanwhile, I'd like to thank you all for joining us today, and I am super grateful for your yeah, this is one of the best attendances we ever had in our webinar sessions. So I'm glad to share the knowledge and ideas with you, but the goal of this presentation was just to highlight what is possible. And if you find something interesting for you, please feel free to reach out, and we will follow up with recording of this so you know how to find us. Thank you very much for joining us today, and have a great evening. Bye-bye.